Okay, this is the second video on algebraic division. I want to have a look at one more example. Once we've done the division, see what we need to do. Have a look at the partial fraction expression that we're going to be left with. Okay. So this case, we have got a cubic expression, and we're dividing it by a quadratic. So an x squared plus 2x plus 1. So my degree for my numerator is going to be order 3. I'm dividing it by degree 2. Now I need to do some algebraic division. I'm going to look at using my algebraic long division. So first of all, how many x squareds go into 4x cubes? Well, that's going to be 4x. So 4x, I'm going to get 3 terms this time. So I'm going to get 4x times x squared is going to give me 4x cubed. I'm going to get plus 8x squared. And I'm going to get plus 4x. I can do my subtraction. So my cubic terms are going to disappear. I've got 2x take away 8x squared, so that's going to give me minus 6x squared. X take away 4x is going to give me minus 3x, and then I'm going to bring down my 4. How many x squareds go into minus 6x squared? Well, that's going to be minus 6. So I've got minus 6x squared. Minus 6 times 2x, that's going to give me minus 12x. And minus 6 times plus 1 is going to give me negative 6. Doing my subtraction, what am I left with? My quadratic terms, my x squared terms cancel. Minus 3x and take away negative 12x is going to give me 9x. 4 take away negative 6 is going to give me plus 10. In this case, I've got a quadratic term. Can't divide it into a linear term, so that's going to be my remainder. So what did we have? We had 4x cubed plus 2x squared plus x plus 4 divided by x squared plus 2x plus 1, and it's equivalent to 4x take away 6 plus my remainder, which is 9x plus 10 over x squared plus 2x plus 1. So I've taken my horrible fraction, I've converted it into a polynomial, linear term in this case, and my fraction. I've got my degree 2, quadratic in the denominator. I've got a linear term, so degree 1 in the numerator. So it's looking pretty good. I haven't quite finished because I want to convert this into 2 partial fractions. Once I've done that, I've got this expression into a format that I can integrate it. At the moment, I'm still going to struggle to integrate this fraction here. But if I convert it into 2 partial fractions, then my life is a lot easier. So what are we going to do? We're going to need to convert 9x plus 10 over x squared plus 2x plus 1 into equivalent fractions. What have we got? Well, this is just x plus 1 all squared. So I've actually got a repeated factor. It's a partial fraction, but it's a little bit trickier. I've got this repeated factor. So I'm going to put it equivalent to a over x plus 1 all squared plus b over x plus 1. I can then use either of my techniques to try and work out what my coefficients a and b are. I'm going to convert this first things first into an equivalent fraction. So I'm going to write it all over x plus 1 all squared. I'm going to get a. I've got x plus 1 already, so I need to multiply the numerator by x plus 1 to get an equivalent fraction. And I can then compare that with my 9x plus 10, because the denominators are the same. This is x plus 1 all squared. This is x plus 1 all squared. My numerators must be the same. So we've got 9x plus 10 is equivalent to a plus b lots of x plus 1. Let's move that onto a new piece of paper. Let's move it up to the top so we can still see it. Okay. We can either use our substitution or equating coefficients. I'm going to have a look at my coefficients of x, because that's going to give me 9 over here. I've got no x's there, I've got b over here, so that's equivalent to b. So b is equal to 9. And then I can either look at the coefficients of my constants, so I could equate 10 with a plus b, or I could substitute x equals negative 1. Let's have a little look at that. So on the left I've got negative 9 plus 10 is equal to 1. I've got a, negative 1, why did I pick that? Well, that bracket's disappeared, so I'm left with a equals 1. Okay. So I then need to just recap and put that back into my expression. So what we've got so far, we've got 4x cubed plus 2x squared plus x plus 4 all divided by x squared plus 2x plus 1 was equivalent to, we had the 4x minus 6, and then we had our plus 9x plus 10 divided by x squared plus 2x plus 1. A little bit far off the screen. This expression here. Well, we've just worked out that is equivalent to a over x plus 1 all squared. My a's got a value of 1, so I've got 1 over x plus 1 all squared, plus b, in this case my value of b is 9, over x plus 1. So I've got this really horrible fraction over here. I've got it into a linear expression plus two partial fractions, all of which I can integrate. So this thing I can't, this expression over here I can integrate. It's the whole reason why we're doing our partial fractions and our algebraic division, to get us into much simpler expressions that we can deal with.